In this lesson, we're going to apply what we've learned so far about vectors to solve a few different word problems. So the first problem says, Angela drives 15 kilometers south and then 12 kilometers west. Determine the magnitude and direction as a quadrant bearing of the resultant displacement. So let's draw a picture of her trip here. Now, it says she drives south and west, so we really need to look at in quadrant 3 for our solution here. So I'm drawing this sort of distorted. So north, east, south, and west. Okay, so she drives 15 kilometers south. And then 12 kilometers west. And we are asked to determine the magnitude and direction of the resultant displacement, which would be here. Okay, so let's label that with an R for resultant. Now, first of all, we would like to find the magnitude of that resultant vector. So we can use the Pythagorean theorem to do that, since this is a right-angled triangle. So we know that R squared will be equal to 15 squared plus 12 squared, which is equal to 369. And if we take the square root of that, we know that the magnitude of that resultant vector is 19.2 kilometers. Now, if we want to find this angle, we could use the tangent ratio. We know that tan theta will equal opposite over adjacent, so 12 over 15. And using the inverse tan function tells us that that angle is 39 degrees. So now we can say the magnitude is 19.2 kilometers. And the direction as a quadrant bearing is south, 39 degrees west. Okay, the next example says a car travels east at 90 kilometers per hour for 3 hours and then north at 80 kilometers per hour for 2 hours. Determine the magnitude and quadrant bearing once again of the resultant displacement. Now, this is the same type of question, except we need to do just a little extra work to figure out the distances traveled because we're given the time elapsed as well as the speed that the car is driving. So, what I mean by that is, if a car travels 90 kilometers per hour for 3 hours, that means that car has driven 270 kilometers. And then north at 80 kilometers per hour for 2 hours means the car has driven 160 kilometers north. So once we figure that out, this is the same type of question. Okay, so we're driving 270 kilometers east and then 160 kilometers north. Okay, and we are asked to find the magnitude and direction of the resultant vector, which would be here. Okay, so once again, we can use Pythagorean theorem to find the magnitude. So R squared will equal 160 squared plus 270 squared, which equals 98,500. And if we take the square root of that, we find the magnitude is approximately 313.8 kilometers. Now, we can use the tangent ratio to find the angle inside this triangle, and then we'll do a slight adjustment to that because in order to express this as a quadrant bearing, what we actually need is this angle here. We need to know how many degrees from north have we traveled. But first we'll find the measure of angle theta. So tan theta in this case would be 160 over 270. Using your inverse tan button, we can see that theta is 31 degrees. And then what I was saying was we need to subtract that from 90, which gives us 59 degrees. So this angle here on your diagram would be 59 degrees. So your direction would be north, 59 degrees east. So therefore, the magnitude is 313.8 kilometers, and the direction is north, 59 degrees east. All right, example 3 says an airplane is flying with airspeed 455 kilometers per hour on a heading of 110 degrees, and there's a 50 kilometer per hour wind blowing from 90 degrees. So our plane is traveling on a heading of 110 degrees. So we'll draw a picture of that. And it's traveling at 455 kilometers per hour. And at the same time, there's a wind blowing from 90 degrees. Now 90 degrees clockwise from north would be blowing directly from the east, is what that means. So we've got another vector here representing the wind speed, and the magnitude there is 50 kilometers per hour. Now in order to find the resultant vector, I need to move that vector down here so that I have them head to tail. So this is my wind vector. So in other words, if my plane was heading on a bearing of 110 degrees, but there's a wind blowing directly from east, then the result would be that my plane would fly in this direction here, because the wind is acting against the plane and moving its path. So let's label this R for a resultant. Okay. Now, we need to fill some other things into our diagram here. So, first off, we know that if the direction of this plane we should say is 110 degrees, then that means that this little angle in here between the positive x measure and the first quadrant, that would be 20 degrees right in here. It's hard to write small with this pen. And because that... So now I could use the cosine law then to find the magnitude of our resultant vector. So we know that the magnitude of r squared will equal 455 squared plus 50 squared minus 2 times 455 times 50 cos 20. And we type that all into the calculator, and don't forget to take the square root, and we find out that the magnitude is 408.3 kilometers per hour. In other words, the resultant speed would be 408.3 kilometers per hour. And I'm not sure we were asked to find the direction. I'm going to go through that with you, though I don't think I did ask you in the question to find the resultant direction, but I do want to go through that with you as an example, so I should have included it in the question. So in other words, we want to find the true heading of this plane, because once you add in the effect of the wind, and then we could figure out the true direction of this plane. So in order to do that, we could use the sine law. So we'll say sine beta. Let's call that angle beta. This little one in here.